Hey, this is Dr. B, and this is a response to some requests that I received last night. We had a help session, which unfortunately I was not able to attend. I want to apologize for that. But what I did was I looked at the discussion board and I saw that people were requesting certain things. There were three things in particular. Where can we find that passphrase? It's a very common issue. I'll go over that. Uh, and let's see, the assignments, question 5 and number 8. So let's have a look at those. I'm on the home page, which you should see here, and I'm going to go to week 3, but I think I'll make it a little bigger here. Now, I'm going to go through this just like you were a student, so there'll be certain delays and things just like you'd experience, but I hope this will help you in case you're having technical issues finding things. So I'm going to hit this little more button to make it bigger. In fact, I want to make this thing full screen so I can see this nice and big. And once this thing shows up, I'm just going to click on week 3. So fine, that's the week we're dealing with. And I'm going to wait for that to open. And once that opens, I am going to go to the assignment. And by the way, before I do that, here's a pre-recording of the video. Now, somewhere in there, perhaps about 10 minutes in, you will find the passphrase. I hope you watch the entire pre-recorded video so that you can it goes over where we're at. And since now it's Thursday, hopefully you've finished the reading, you've finished watching the videos, you attended the live classroom, you had an extra day to work on the reading and the videos. Great, you understand bonding chemical compounds and their formulas. You've emailed me with questions. You've posted questions to the discussion board so we can crowdsource these problems. It's never a good idea to try to solve everything on your own. You've worked through lab number 1. You attended the live review, which is kind of what we're doing right now. It's now Thursday and you're working through the gravimetric analysis, but the questions were on the assignment, so some of you are a little ahead of schedule. So I'm going to click on that. This is what I call the template. This is designed to show all the questions and provide them in a manner where you can go ahead and solve them on your own. Now, I always prefer to work on the desktop app, so I'm going to wait for this to load enough so that I can do that. And see, it's not there yet, but once this thing makes it so that I can work in the desktop app, I always prefer that environment. And it's still slowly loading. And, so that's realistic with what you guys have to deal with. Maybe it's about, it's finally lit up. So I'm going to go ahead and click on that. And I prefer to go into that environment. And here it is. And I've already blown it up a little bit because I've been, I rehearsed this a little bit for you guys. So I want to go over questions number 5 and number 8. I won't provide the exact solutions, but I'll give you enough information that you can get started. Okay, so let's do question number 5 first. It says calculate the mass percent of about a half a gram of H, which reacted with oxygen, and it formed 2.32 grams of water. Now what we'll do is find out how much hydrogen was necessary to form 2.32 grams of water. And the question itself suggests that you didn't need all that 0.485 grams. There was a little bit of excess. We'll find the percent that was needed. I'm going to solve it directly in here because you can see that when I click, there it is. I can go ahead and enter things. So the first thing is we're going to find, I don't want that to be highlighted. So maybe that's off. Let me highlight this and make sure that that's off. Why is it giving me this highlight thing? No color. So we'll find the mass of hydrogen used. In other words, we had 2.32 grams of water that was formed, but not all of it was used. So I'm just going to make this nice and clean, and I'm going to go to the equation editor here and just get a little fraction going, because for every 18.0 grams of water that is formed, That's a mole. We get that from looking on the periodic table and finding the average atomic masses. We've got 2 hydrogens, each that checks in at about 1.0 grams per mole. And we've got 1 oxygen that checks in at 16.0 grams per mole. So for every 18 grams of water, can you see that only 2 grams came from hydrogen, since they're much smaller and lighter atoms? That'll give us, really, that shows you that water is less than 10% hydrogen by mass. So we are only expecting about maybe 2.23 grams or so, which makes sense because we have an excess, 0.485 grams. So I'm going to write 2.0 grams of hydrogen. And that should tell us how many grams of hydrogen were used. And it is 0.259 grams of hydrogen were used. I like that number because it's less than 0.485. Now, since this is a real sort of problem, I want to clean this up for you so when I hand it in, I'm going to make it nice. So for this equation, I'd like to use normal text, and I have this obsession with my font, so I'll make the whole thing that font. See how it did that? Further cleaning it up, I can make that a subscript. There you go, maybe a little space there. And I think that looks good. Now, the second thing I'd like to figure out is the percent of hydrogen used to find mass percent of hydrogen used. And I just can't abide by that font, right? So let me just change that to the font I prefer. And for that, we'll use a little fraction, so I think I'll copy that one and just change it, right? And there it is. And so for here, we had 0.259 grams of hydrogen, and I might not have entered a 0 there. There it is. But we have more than that available. We had 0.485 grams of hydrogen was available. And to turn that into a percent, we multiply it by 100%. That's percent. And we get 53.4%. And that is the mass percent of hydrogen. Now let's do a little bit more cleaning up here so that when you guys hand this in, they look absolutely beautiful. A gram of water divided by a gram of water equals 1. That's why we set these things up so that the units work perfectly. Cleaning up our fonts here. And recognizing that a gram of hydrogen shouldn't be written twice. And a gram of hydrogen divided by a gram of hydrogen also cancels. And sometimes it's hard to highlight just the parts that you want. See how it does that? Ugh, it's annoying. Sometimes you have to go a little bigger until it just gives you what you want. And in fact, I'm not going to get there, I don't think. So I'm just going to give up and underline it this way. And manually add the H. Ha ha. Gotcha. And so that cancels. Oh, now I gotta need the little gram there. Oh, and that didn't underline, so not giving up. Gotta underline that. Okay, geez. Okay, so it's underlined. And the only thing I might want to do at the end is make that pretty and highlighted, which some of you have done for me, and I kind of like that. So good. That is an answer to number 5 using the same annoying level of cleanliness. Let's try number 8. Now, I'm not going to solve this whole thing for you again, but I'm going to give you a little bit of assistance. Let's read the question. Glucose is a carbohydrate that contains carbon, hydrogen, and oxygen. Right. The empirical formula is you always have, for every 1 carbon, you have 2 hydrogens and 1 oxygen. That means it's the simplest ratio. They want the molecular formula. And by that, they mean it's going to be some multiple of that. Sure, there's a ratio of 1 to 2 to 1, but that could also mean that it's C2H4O2, C3H6O3, etc. And to do that, all we need to do is scale it. We find the molecular weight of the empirical formula, and it'll be some multiple that gives you the 180. Maybe it'll add up to 90 and we have to double everything. Maybe it'll only add up to 18 and we got to multiply everything by 10. So the steps are: 1, find molar mass of CH2O. Let's make that a subscript. Now I'll be doing that throughout just because I'm hoping when you guys hand it in, you make it look all clean too. It just looks so nice, right? And so when we do that, we'll find that that is, look up your molar masses, grab that periodic table. It's the thing with the decimal places. 12.011 plus 2 times the 1.008 for the hydrogen plus the 16.00 for the oxygen, and we should get about 12 plus 2 is 14 plus 16 is 30, and I got 30.03. And let me make sure we have units here, since let's just call these atomic mass units. We could also call them grams per mole, but there they are, 30.03. Yeah, 30.03 AMUs. Now to scale to get molecular formula. Now if you're really just working slow, you could say, okay, double it gives me 60, triple it gives me 90. But to do that, I guess technically you divide the molecular formula by the empirical formula mass. The empirical molecular, the molecular mass divided by the empirical mass, there it is, and that should give you some scaling factor, right? So I will maybe copy from my little fraction that I had here so I don't have to do too much from scratch, and put it about here. And we have, what is it? CH2O checked in at 30.03, but the total is 180.12. So I'm going to write 180.12 AMUs divided by, careful, you got to make sure you only get the part you want, divided by 30.03 AMUs. And let's clean this up. Well, how about I'll do everything. Maybe you could just like check out at that point. And that's going to be equal to 6.0. That's our scaling factor. Everything needs to be multiplied by 6.0. So molecular formula equals 6, right? So I guess we'd get C6H12O6. And it just needs a lot of cleaning up at this point. I don't want it to strike through. I do want all one font. I do want, when it does this thing for you, that's annoying. You need to click on equation and have it be normal text. And then you need to make sure it's the font you want. Since I've done this a million times, I'm kind of familiar with it. That's true for the whole thing. I don't like that font. So now I have the font I want, almost. Let's try that. And see, when it doesn't click like that, you just have to go back to normal text and then change it. But you'll get there. Clearly, they could do better to help you along here, but there it is. And let's change those to subscripts. I have a secret weapon that I've used, which is called Chem Formatter. And when you click on that, it changed everything for you, made those 3 subscripts for you. Is there anything else that needs cleaning up? Yeah, I don't think I want that strike through, but AMUs does cancel. So being as ridiculously accurate as possible about this. Aha! We have everything stricken through. We've got enough space there. We've got our final answer. We'll highlight that. And this is the answers to number 5. Once again, not giving you everything, although maybe I am. For number 5 and number 8, and also don't forget where you can find your passphrase. Okay, send me those emails, place things on the discussion board. Let me know if you have any other questions.